Hello, everybody. Oh, you guys can hear me. This is perfect. Welcome, everybody. Thank you for being here. This is one of the last sessions today, right? Good.
Full day.
So my name is Zlatan. I'm a senior solutions architect for our specialist team on the partner side, and this is Nick. We'll do the introductions now.
Okay.
He's actually part of my team. We're going to be talking to you today about driving innovation with serverless applications. So we're going to look to cover as much about serverless and what it means to us and how you can kind of build and create innovative solutions using serverless. Where does it come from? How do we progress? How do we get there? And all that. This is a level 200 session. We are super deep in this stuff, so please feel free to come and reach out to us after the session if you have any specific questions or if you don't want to dive deep into any of the subjects we're going to cover today. So, a little bit about me. Kiptonian in Orange County. So I've been living here now for 8 years. Originally from South Africa. And one cool thing for you to know, whether you know or not, but AWS was first created and started in South Africa, in Cape Town, in fact. And our main Amazon Development Center is still in Cape Town. The core development teams for EC2 and the rest of them are still in Cape Town. So I was there again now for 5 weeks recently, and it was great to actually work with and see what the product teams are doing and all that. Very fun. So this is Nick.
Yeah, so I'm Nick Nadaf, same team like Zlatan. I'm based in Canada, though the only one left alone there, so supporting partners on Microsoft platform in Canada. I joined this team almost a half a year ago, but I was with Amazon for 3 years.
Nice. So, why are we here today? We're here to talk about what serverless means to us, right? So what does it really mean? Well, there's no service to provision or manage. You can basically scale as you use it, so you don't have to worry about any infrastructure aspect of running, whether it's actual availability, scalability, whether it's vertical or horizontal, any of that, self-healing and all these things. You never have to pay for any of your idle resources. Taking really the whole cost-effective nature and cost aspect of well-architected to its final kind of level, and obviously, with many of the other, I want to say, services and features built in. Not just availability and scalability and fault tolerance, but also integration into various other services on our side, both managed and others. So it's the ease of use and implicit way of using all of our resources and taking advantage of the cloud to the fullest. So how do we get there, right? We have started with monolithic applications, and for the most part, and it doesn't really matter, kind of on which platform and what you worked on. Monolith has been a way, of the game. And then we kind of progressed onto the microservices, and then we ended up on the serverless function side of things. So splitting monoliths, this is more than 10 years ago at this point, right? It was fairly slow, right? We realized that we have asymmetric use of resources, that we have transactional services as well as batch services running on the same, and they were using, both the RAM and CPU differently, and all that sort of stuff, oversaturating what the other service was doing, and then we ended up having to expand and spend copious amounts of money on extremely large hardware for an application that just wasn't built to use it properly, and it was using 10 times resources than it should have. Splitting it up was fairly difficult. We were using things like SOAP and XML. Remember back in the days when XML was a keyword that people were putting in their resumes? I know XML. I'm so glad that's over. Now we have blockchain, right? But anyway, so coming to that, how do we grow from there? We started splitting it up with much faster protocols, with much faster services. We started using REST JSON and fast binary encoding. So that allowed us to actually split it up into, obviously, more microservices that we ended up containerizing as Docker came out with Swarm and other things. Now we have Kubernetes, we have ECS, we have all these great and wonderful things. With that, we started actually creating these microservices architectures that started kind of spreading and scaling very easily. We focused on the stateless and serverless, rather stateless side of things, and to kind of simplify it, it's when we kind of switched over to containers, that also meant that we could actually instantaneously start up these services where if they fail or not. There was no need for you to focus anymore on having to log in and administer individual servers or worry about it. You can just discard it. We came into the whole age of disposable architecture, right? And you can bring up new healthy instances in a matter of seconds. What really helped with the whole thing is that, as you know, containerization is not virtualization, right? And it's not an overlay of another operating system that is running on top of it. That means that these services, in theory, are always running, and you just have to bring it up. So then we kind of saw that as like, hey, why have to worry about the infrastructure aspects of running on top of, running our clusters on, whether it's EC2 architecture or on-prem architecture, and all of that sort of stuff, having to run and maintain all these aspects. Why not, go ahead and worry about just the code and business logic that we need to create and build? So this is when we kind of started transitioning over from microservices to functions. We started creating, we saw that there were some common components in serverless architecture, or rather in architecture in general, that could be abstracted out and be provided as managed services. And we kind of called it as part of our serverless architecture. So you'll see services like API Gateway, S3, SNS, amazing service, Kinesis, DynamoDB, SQS, many others. And then, these services were commonly used also in kind of microservices architecture to abstract that kind of complexity and functionality out of old monolithic kind of applications as part of the whole refactoring. And now, we've seen that by using actual lambdas to build out that business logic, we can actually, for the most part, also do away with having to run a lot of these workloads on containers as well. So we split up that business logic into separate lambdas, and we define, quite simply how they work between us and how the API gateway uses SQS and how it uses DynamoDB and Kinesis, or how it uses S3 and SNS. And one of the biggest things is that, with any of these services, as soon as you don't use it, if it's idle, it shuts down and it costs nothing to run. Does it shut down or not, you don't really care about it. All you do care about the fact that you're not paying for it anymore, right? And it's been great. I mean, just for some simple examples around the fact that, you had from simple services that you would be running on EC2, you would have to have even the smallest instance, if you're using like T2s or whatever the case is, you still would have to kind of permanently run this. I did some simple calculations, and I know these things change as we kind of become cheaper and cheaper with larger scale, but even at the most expensive, like if you were to invoke Lambda, every minute, we found that that cost like a couple of cents a month or something like that. It was incredibly cheap, a couple of dollars or something like that. But it was negligible compared to actually permanently running existing instances, whether they be RIs or on demand, of course. So as the evolution, we're going to kind of transition over now to to the core of this solar system, so to speak, that is Lambda.
Yeah, so just talking about the core component of the serverless application, or Lambda specifically, is you have the event source, which is an entity, AWS service that triggers or publish the event, and the code that is actually listening and responding to this event, and then the code is going to be actually managing or dealing with another service. So that's actually the core component of how the Lambda function is working. That's what we call it, the event source mapping, is between the event and the code that is handling that event. So we have like common Lambda use cases, or we can use Lambda function. Is mainly the first one is the web application, where you have either static websites that handling with the backend based on Lambda, or complex web application that has based on, for example, ASP.NET Core or another programming or dev platform dealing with Lambda as a backend to handle stuff. The second thing is the backend, where you build complete serverless backend based on Lambda and other services that, like DynamoDB, and fully functional based on the serverless architecture, specifically Lambda functions. Also, you can use Lambda to handle data processing when you deal with real-time data using Kinesis to get Lambda receiving data from Kinesis, or actually they're getting data from somewhere else and splitting them to mappers, where you can use several mappers handling the data. And also they can be powering a chat bot as a backend to support this kind of application. The core thing also for Alexa, every Alexa skill is based on Lambda function. It's just the way is actually the Alexa skill is Lambda function handling all the stuff and just connected to the skill using the Amazon Dev Portal, where you can assign what your skill name and ID and what is the Lambda function supporting the skill. Last one is when you use Lambda for IT automation, is you can use it to extend, for example, the CloudFormation by using macros, or you can use it to support the policy engine, where you can manage your infrastructure and handling stuff inside your Amazon resources. This is actually just serverless architecture, where you can use multiple AWS serverless services. The main thing, you have the client, which is the browser, web application, static websites, a mobile application, Alexa skills, dealing with API gateways, API where you can this API could be using multiple Lambda functions orchestrated by step function or individual one, and you can have the backend as a database backend, DynamoDB, RDS, Elastic Cache, or all of them. It depends on the complexity of your service. Also, you can use SQS to handle things, in the message queue based system, using the SNS for notification. Same thing you can use, instead of going directly from in terms of mobile, has to go to use the web API or API gateway API directly. If the browser can be hosted as a static website hosted in S3 or behind CloudFormation, CloudFront distribution, and then this application or this website is calling the API to get the dynamic content from the serverless backend system.
Cool. So a couple of things on that sort of stuff. I mean, it's really all about getting you guys, if you haven't actually tried any of the Lambda or the serverless applications and all that, in kind of where to start. So a couple of things on the examples that we've had over here. Chatbots and stuff. If you use Amazon Lex, for example, which is Alexa actually uses it as as officially part of our AI offering. You can create bots that are easily there. We have blueprints for Lambdas that can take advantage of those bots, like order flowers, and then literally in minutes, you can create intelligent bots using AI that are completely serverless and that you can deploy and use within your organization. Things like IT automation, those are very quick and easy wins around basically hooking into any event. So we talked about, Nick talked about the event-based invocation of Lambda. So it can be anything. It can be any security event. It can be any administration event or anything like that that will actually, demand some sort of, I guess, ops or administrative action that Lambda can kind of do and automate. So things like informing, I've been building like bots that inform SecOps teams about, changes in security groups, specifically in AWS environments, and allowing them through Slack to send commands back through Lambda, through API gateway, back to the environment to either fix it, change it back, or perform other administrative actions. There was a whole bunch of different config actions as well that you can automate, and in that way, really making your life and everybody else's life a lot easier when it comes to that, as well as allow you to, even manual actions that you take for those to be exposed to as little as possible of like human error that can be introduced in any way. As we know, it's almost impossible really to automate everything. It's really all about doing as much as possible to kind of make any manual, any active action as easy and as precise as possible. So now you kind of know the basics and all that. One of the first questions that comes across is, hey, I've looked at your Lambda. I looked at your serverless services that you have in there and all that. They're very easy to configure. Lambda is very easy to like start programming and put your code in a browser and stuff. This is great demoware. I did it at my company. Everybody loved it. But when I started thinking about, hey, how does this now apply to the way we actually do both testing, the way we do deployments, the way we do all these basic things that I was doing before, whether it was on-prem and whether it was with EC2 instances and all that. How do I integrate this into our CDCI pipelines, which I'm going to touch on as well? And how does this now make sense? Because think about it, right? There's different set of packages. Now, when you transition over to serverless architecture, that means that everything that you're deploying, instead of being code, for the most part is actually infrastructure, if you think about it, right? Except the actual code that is part of the Lambda package itself. So you want to make sure, pretty basic things, whether it's, syntax issues, it meets your company standards, it can meet any compliance requirements that you may have, depending on what industry you're in. You want to make sure that it's sufficiently tested, not just at the code level by a unit test, but also you want to make sure that it's sufficiently tested within all the components of that architecture, right? You could actually be deploying Lambda, and it works perfectly, and it runs through, through all your test cases just fine. But once it actually starts interacting with the rest of the services, it introduces other issues that you were not aware of. And so you need to kind of create that end-to-end testing aspect, and then that's the whole functions end-to-end. And obviously, you need to make sure that it follows best practices, of course, because a lot of these services are managed. A lot of these things are in our court, which is actually making it easier for you. But there's always ways in which you can, expose yourself if you don't, if you don't consider best practices, even in serverless architectures themselves. You also have to have appropriate mechanism. What happens if it fails? Because this all seems almost monolithic in a way, in a sense like, if it works, it works. What if it actually fails, right? Because anything can fail. What is that our CTO says, Werner Vogel? The only thing that is certain is that services will fail. So you gotta be ready for that. So what are the things? Let's start off with the very basics on what you're going to start off, and then we're going to kind of transition over how that looks like. I will talk about how that plugs into the actual CI pipelines and all that. So building the deployment package. We do support these four main, well, five actually, languages. So you have Node.js, Python, you have Java, C#, .NET Core, or Go. We have been working tirelessly to make these packages as, obviously, as fast as possible. So deployment is as fast as possible in our environment. We continuously improve upon that. So it's almost, to the point where it will be seamless at some point. We have a lot of services that we normally use and that you may already be using as part of the deployment with your normal, EC2 kind of application deployments that you have. It could be also, you could be using things like, I don't know, third party like Jenkins and VSTS and all this sort of stuff. Just the same, we have support for Lambda. Code build, and I'm going to single that out because it's a great service. Because it can, not only is it fully managed, but it can both build your packages and run tests on it. It can scale continuously and process like multiple packages in parallel or in sequence. It can actually do some basic orchestration, which a lot of our customers need, between multiple builds and how they relate to each other. And it can, besides consuming environment variables and parameter stores, which actually makes it fairly kind of easy for any configuration aspects that you want to kind of maintain. It can run in your VPC, and before it had to be outside, and support dependency caching. But more importantly, it's really simple to configure, and it is something that you don't need to kind of learn the new product from the get-go. It's literally much like code deploy with AppSpec. It has this build spec YAML file that you actually put at the root, right, of the package itself, and it has very, very simply put in what your input file is and where it comes from, and then it breaks it down to phases. So you'll say on install, pre-build, build, and you literally put in the commands that you want to run at each of those phases. You could also be referencing existing, I want to say kind that you just want to execute that actually have all of these commands pre-written. You don't need to kind of know the new product. It's very kind of implicit. Install, pre-build, build. You write your own script. You literally transition your own stuff over, and then you have post-build commands and artifacts that it builds with it. So, if you want to kind of make heads and tails of it, top is the variables used by the phases of build, and then these are the examples of what you can do, and then how the artifacts gets created and stored in S3 at the very end of it. There are great things that you can do. Besides, if you want to kind of check out different testing services and solutions, there's Landscape, Code Climate, and Coveralls.io. We've had a lot of questions from a lot of developers on how to actually use mocking or stubbing tools, meaning that development. One of the biggest challenges is that development of something like serverless depends on you being obviously on the internet the entire time and being connected to your account and all that. However, since you guys are taking pictures, make sure you'll have this available at the end, and I think this whole thing will be available on YouTube. But check out that first link. And it has many stubs that actually stubs all of our serverless services and mocks them, right? So you can actually work offline completely, and you can test it out using the services and all that, and then you can deploy when you're back online, right? And that's a great thing. That is something that has been missing for a while. There are things like also Bodo mock tool, DynamoDB testing tool, and Kinesis testing tool. As you can imagine, besides running the actual unit tests that you can do on a code, and never mind the syntax and the whole thing, depending on your IDE, but you could also, most of the testing is going to be through API, right? And so you can use something like GroundScope API or Ghost Inspector to actually do the API interface and UI testing. So with this, you've really just scratched the very basics, right? And I'm going to talk to you about how that kind of plugs into the full CDCI pipeline after Nick covers the metrics. But with that, you got the basics of, hey, now I have the my ID set up. Now I've created my package. Now this thing has to be built and deployed, tested, and deployed into the environment. So I have the basics of putting the basic testing and the basic checks and balances in place to make sure that what I'm putting up front and what is being used from a serverless perspective is in fact valid and running and up to the standards of my company. So I'll hand over to Nick.
Thank you. So as Zlatan explained, like you have now tools that you can get the stuff local, you can attach debuggers, start doing stuff. But when it comes to deployed services, you need to see what's happening there because things happening after you finalize and finish everything was working well. You need to start actually checking the metrics, checking the logs to make sure everything is working fine. And if there's an issue, you need to know where's the issue. Is it in like this area? Is it because of API gateway? Is it because of Lambda? So you start depending on metrics. And for Lambda, you have built-in metrics that give you information about what's happening in your code execution. For example, if you're gonna see like the invocation count, you're gonna check the duration, the errors. You wanna see, for example, the iterated age. That's what you do when you're dealing with Kinesis, when you're handling real-time data. And you wanna see if you have any DLQ errors. We're gonna talk about later. And the concurrency, same thing when you are actually connecting Lambda with API gateway, you're gonna know exactly where's the error. That's why, or where's the problem. That's why you have built-in metrics for Lambda. Same thing for API gateway, where you can see like the call counts, the latency. You're gonna see the client error or server error, and you wanna see the integration latency. Means like if your API gateway calling another service, and you want to see, okay, how much time is spending on this call to the other service or the whole thing. So, and you want to see if like this kind of the cache, because API gateway has its own cache. So you're going to see like how many requests hitting the cache or how many of them missing the cache and going directly to the source of information by calling the service after the the API gateway. So those built-in metrics are going to help you when you deploy your service and start doing application in production. You want to keep always watching what's happening in your service or your application to keep track on if it's going well, if it's not, where's the issue. Because usually when you have like serverless an application, it's not only one service. You have like a couple of services, as I showed you before. You have the API gateway, you have Lambda, you have DynamoDB, you have S3, you have So you need to check each part if there's any issue, and if there's an issue, where it is this issue. Is it latency? Is it duration? Is it like whatever? So once you deploy and start running your application, you're going to see all this data metrics in the console. You start checking the invocation count, the one that I showed you before, the built-in metrics. You can see this in the console and start checking all this data to make sure your service is working well or to see where's the problem. So you have the metrics and logging where you can get the information. You have now data coming from metrics, from API gateway, from Lambda, and you can just pivot this logs just to see the whole data as a like the big picture. and you can either like, search this data and connect it to other services, like visualize this logs to see, the whole picture about your service, serverless service or the whole application. And then here, for example, you see like, this is a sample of like one of the metrics where you see the call, you see the IP, the caller, you see the date, what kind of, the HTTP method, is it GET, is it POST, the URL, the status, is it okay? If it's not okay, you're gonna see, the 400, that means it's a client issue, or 500, there's a server issue. So each metric, data, you're gonna see it in this, the console to make sure. Yeah, or you can exactly.
Customize the way you want to see it and how you want to have it structured. So it can get consumed, whether it's consumed by a third-party application, third-party service. It can be consumed by Splunk Datadog on one side. It can be consumed by your Elk Stack or Elasticsearch and all that. So those, and presented with Kibana and all that. So you can kind of create an relationship as well, and the format as well.
Because once you start, really going in serverless, beside coding and other stuff that you're doing, you need to make sure how it's, working, and you need to keep watching your services and your application day and maybe hours, just to make sure everything is going fine, because that's going to be affected by your load, how many requests you're getting. Your code is going to be tested on certain thing, but maybe later you're going to have different situation. So the logs and metrics, they're going to give you full information on how, if you're going to change if you want to, or you need to change your service, how you're going to do it and what you're going to be fixing or covering. As Zlatan explained, like you see like here, different, visualize on your logs and metrics data from your, service.
It's important to look at the invocations, and you look at, you can have errors for different things. Your calls that your Lambda makes can time out, or whatever is actually making a connection, or rather, it's calling up your API gateway and all that. And that can happen for various reasons. It could be because the source went offline. It could be a third-party service that went offline, the connection went down, or maybe the actual service itself went down. Or maybe the fact that on some change from a security perspective has impacted this temporarily and all that. So it does provide you also with forensics around back. So you need to kind of look at, a lot of times when I did reviews, I would do health checks with various customers that have used serverless and Lambda extensively. We would actually have to take a look at the forensic analysis of exactly how the Lambdas have been executed against various different sources. I mean, one of the first things and one of the first use cases that you see, we often in the past and still call Lambda the store procedures in the sky. In the cloud, it's basically looking to abstract, and that's part of the whole thing that I was talking about initially. The actual refactoring and abstracting the monolithic aspects of your old applications. So one of the most monolithic aspects is that a lot of people have been building the entire, data layer, even the business logic through through store procedures, in SQLs and the likes, and that doesn't scale, right? It only scales vertically, and that's fairly difficult. It doesn't scale horizontally. So first thing was to abstract it and rewrite those in Lambdas alone. Sometimes there's a lot of interdependencies between multiple ones, and those interdependencies can only, can kind of hit certain issues in specific conditions. So doing forensics through, like I said, what Nick said, through, looking at the metrics that are presented to you through CloudWatch alone can kind of give you that analysis and clues to what and how to manage it.
Okay, so as I explained before, you have metrics for Lambda, for API gateway, but sometimes you have, like, if you're working on microservices architecture and you have one of the services completely serverless, and you have so many services included, like you're calling the API gateway calling Lambda, then Lambda is going to S3, DynamoDB, SQS, so you have like many layers. You want to see the whole picture of like how this end-to-end, logging is happening in terms of latency, HTTP, some metadata. So that's why you use the AWS X-Ray. You enable it, and then you can see, the whole thing. So it starts tracing your request, and then, record those traces, and you can see and view the, the whole service, data or traces coming, and then you can start checking some information, the HTTP, response, or like the status, the latency, the error, the issue. So it's going to give you like a full overview from the request coming, the first thing, and then the response. So instead of following one by one, that's going to go details, that's going to give you like overview of the whole request response, life cycle.
And individual API calls and all that, and you can literally just drill through and find out forensically.
Yeah, so usually you need to use both actually, but just each one is giving you different kind of information, and you're focusing on different kind of, debugging and so this is just, sample using, Lambda, where you can, trigger or like capture, start capturing the data for X-ray, and then you assign the handler, and you start, calling. So this is just an example of X-ray service map. It starts from the client, and every service, like you see it in green, and it tells you, the latency, the time, and some other information. So now you have 3, but if your service, for example, calling like the API gateway, Lambda going to S3, and then you're going to DynamoDB, or you're going to others, so you're going to see more, depends on what kind of calls you're going from end to end for your service.
And one of the things on there, through the code itself, I mean, for those of you that have actually tried any kind of, very simple Lambda that you've written, you would see that the code doesn't differ much from it. If you want to include and get X-ray to start tracing it, all you have to do is just declare, the main AWS, kind of API invocation under X-ray for X-ray to kind of start tracing it, and then your code remains the same.
Yeah, so like
it's exactly the same. So it's very simple for developers to introduce it, and it gives you plethora of data, as you can see, whether it's very graphical or whether it's in tables like this. Go ahead, sorry.
Yeah, so like when you're working, especially like I'm talking about like as my team focusing on Microsoft, or we use Visual Studio to build Lambda function with API, gateway, and you can just, when you start deploying, it's just enabling this is just easy to put X-ray as part of your function and start watching the logs and information on the console. Here it's just telling you that, okay, your application is functioning well. In terms of the green, you see all the information in terms of latency, milliseconds, and each part of your service is actually recorded here as part of the logging, as part of the recording your end-to-end X-ray.
Yeah, it's interesting. It shows you the attempt 1. So Lambda will make 3 attempts if it fails before it gives up. so you will see attempts that it's making, and how much time it's taking, and why, and all that. So yeah, go ahead.
So in general, when you start actually checking the logs or logging inside your service, you need to use, as we said before, the X-ray, the built-in Lambda debugging, where you can put in your code debug statement. And if, for example, if you're using Visual Studio to check or execute Lambda, you can execute Lambda from Visual Studio, and you're going to see inside Visual Studio all the logs that you put in function. And when you see any problem, you just fix the code, compile it, and publish it from Visual Studio, and then you check again, the debug. So using X-ray, using
the dumbest stuff, just console log and put in like what the value is.
But at least you can, you're watching, because
structural programming debugging works really well.
Because you can't attach a debugger, so you have to do something else. And plus, of course, you can use always custom metrics for your own service. That's on the top of what's inside Lambda and API Gateway and other services, because you want to log and watch some custom values as a part of your own application. So this is actually another a feature in Lambda where when you call Lambda asynchronously, then when the function fails, then if you don't enable to have the dead letter Q, then the function is going to be discarded and nothing's going to happen. But just to avoid having this issue, you can just use this feature to publish this in SNS notification or in a topic or in SQS queue, so you can get something else, another service that goes and check what happened in this call, why it failed, and then you can try to check again or try it again. Because Lambda function will try it and then it will give up, and then if there's not if the dead letter Q is not enabled, it's just going to discard it and ignore it and give up. But if you enable this, it's going to publish this in SQS queue or SNS topic, so another service can take over and start checking and continue the execution.
I'm putting it in a whatever data storage for analysis later. But that letter Q is extremely important. And like I said, that's 3 times.
Yeah.
There, yeah. Oh yeah. So if we haven't confused you enough, building the pipeline. so now kind of you have down the basics and around kind of why you would use Lambda, not just Lambda, serverless services as a whole, and Lambda at the heart of it, and kind of break it up according to different functions and all that. Of course, there are things. I mean, you can actually run things like Web API on, with C# and Razor Pages and other things on Lambda, but for the most part, basically Lambda is not your web front end, right? It is usually, kind of deployed in conjunction with, let's say, WFEs that are actually running either on your ECS or Kubernetes cluster, or they could be in fact running on EC2. And they're kind of using other, where you abstracted in Lambdas, you abstracted both the application or and the data layer, or just the data layer, and all that sort of stuff. And any aspect and any service that is fairly demanding, requires a lot of attention. It's critical from a production perspective. Needs to scale almost infinitely, and you want to kind of take care of that. One of the biggest things around this and challenges that customers have, that's the main challenge with microservices architecture to begin with. So some of you, I don't know how many of you know what is the main challenge. Is that when you fracture out your application architecture to too many services, it's very difficult to keep up track of each of every one of it, and maintaining the same versioning and same kind of compatibility for each and every aspect of the microservices architecture. What has prompted a lot of developers is to start going back to the monolithic architecture. so started going back and all that sort of stuff. That's not great. I mean, initial things around what we were doing, let's say with containers, we could be deploying under different kind of instance types, and we could be deploying kind of web optimized services, batch optimized services, want to say storage optimized services, memory optimized services, and run them on an appropriate kind of underlying architecture based on that. So you would create an affinity on certain servers in a cluster, and then you would say, cool, you memory optimized guys go to whatever, I'm memory optimized, you guys go over here, you guys go over here, and then your containers would, like your orchestration would worry about your containers going to the right servers and all this sort of stuff. You do want to you don't want to fracture those out too much. You do want to kind of really keep it down to the underlying architecture, hardware architecture, and how it fits. Don't fracture it out based on business logic, because then you'll be fracturing it out forever. So how do you build a pipeline for that? So the main aspects of building a pipeline is really source, build, test, and production. So for source, you want to check in your source code, and that could be your source code that is for for your Lambda function, but it's not just for your Lambda function. It's also the actual CloudFormation, or rather serverless application model, which is kind of a subset of the CloudFormation used to deploy serverless architectures. So it's an infrastructure component as well as the actual code component. And there's build. You need to compile that. You need to run unit tests. You need to run establish all the code metrics and create the deployable artifacts. Then you need to run your integration tests, not just between Lambdas, but with all the other systems and services, perhaps load testing, UI testing, and penetration testing, and then you would kind of be deploying that into production. So you need a continuous integration, delivery, and deployment that follows that. So code pipeline, much like for the actual source code, would be used to actually orchestrate all of this. So you can establish continuous delivery of your serverless application and serverless services and serverless application architecture continuously. And with code pipeline, if you have used it or not have used it, it's fairly easy to kind of establish that, and I'll kind of break it down into different things. So this is kind of an example of a minimal developer pipeline. You would then basically reference a source to where your ID is storing, or where you are storing the source code, pushing it out as you're kind of building it. And then it would immediately kind of trigger the code build, which would then both build and test. And then you can then deploy it into what would be your development environment. So what's really cool about serverless is that you don't need like separate server environment and all that for development, QA, and all that. It can all be the same function that is kind of defined by a different version, which is defined by a different alias. So each version will carry an alias. One will be version 1.1 can be dev version, version 1.0 could be the QA version, and 0.9 could be the production version, and all that. So it can all kind of live in one place without you having to worry about multiple environments. So your ops team and the rest of them don't have to worry about that overhead. And then kind of you would then create and execute change sets and then run tests on it. This is a more kind of minimalist production pipeline. And as such, you can kind of also introduce manual sign-offs. You can use external testing tools, not just our internal ones, like RunScope API and all that we talked about. And it includes both the deployment testing of the infrastructure and the code aspects of it. So I don't expect you to know this and straight away, but this is kind of the aspect, something to bear in mind, something to, if you're a developer, it will be very beneficial for you. If you're not, it's something to bear in mind around what are the key stages and key aspects and services integrations used when you do talk to your developers around and explain, viability and ways of, using serverless applications, testing and deployment of the same. So before we didn't have, Code Deploy was mainly working kind of with kind of, classic EC2 deployments and all that. Almost a year ago and all that, we started not only having Code Deploy that supports Lambda deployments in the context of serverless architectures, but also it supports things like Lambda alias traffic shifting, and that's the alias that I talked about, where you can enable both Canary and blue-green deployments. And I know this sounds like Spanish right now, but what's really cool about Canary deployments is that how would you test something that you just deployed even if you don't know about it? Even if it went past all of your tests in both test and QA before going out to production. If you want to be absolutely sure that the production level workloads are not going to be affected, because that could be at a much larger scale, right? If you are working for a let's say a retail company and you have to manage the load that is going to come through, during Black Friday sales that is coming through. You probably shouldn't be introducing new new code during Black Friday, but we have something called Canary Deployments, which means that you can actually say, give 5% of the traffic over to these serverless components. And let's test it out first. And once we are satisfied, we'll be monitoring all these aspects that Nick was talking about. Go ahead and start increasing that percentage until we are happy with it. We can also just as easily roll back without anybody knowing and without any downtime. Same goes for blue-green deployments. Blue-green deployment refers to basically bringing up another set of infrastructure right over there and then doing basically connection draining and shifting traffic from one to another, right? Very cool stuff. Code Deploy has a really cool kind of graphical interface that shows you how that's happening in real time. So it's really good to put it up on a massive screen and see how these things are happening. You can then, also design like rollback based on metrics and alarms. You'll find out that CloudWatch is very good about identifying different, events and all that, and you can hook into those events. And if it's a familiar event that should result in a rollback, then you can kind of program that rollback. And that comes into that whole automation of the infrastructure. You can have another Lambda that goes and hits the rollback on that. In this case, you can actually set a rollback and directly through Code Deploy itself. And then you have pre and post traffic triggers that can actually integrate with other services besides calling Lambda, like I mentioned now. So this is what I was talking about. You can say, hey, Canary 5% for 1 hour, or you can have a linear 20% every 1 hour to kind of custom deployment configurations that you can have, for your serverless architectures. Once again, you can take advantage of sending these things to to SNS or SQS or SNS is great. I love SNS in the sense that it will take any level of messages and things that it gets sent, and it can then send it out to other services, or it can actually send you SMSs to your phone as well as emails and all kinds of crazy things. So it can form part of your architecture, or it can be a mechanism for informing you and sending you important things directly to you as a person. And then, so what are the kind of best practices to remember when adopting kind of serverless architectures and all that sort of stuff? Because I know it was a really compelling story when I had these cool animations and stuff like, oh my God, just abstracted all your monolithic code, all that heavy technical debt that you had, into these clean and awesome functions that you have. So we touched on blue-green and Canary deployments. You want to make sure that you use Lambda versioning. Please, those things are not very obvious from our side, I think, because from a console perspective, we try way too hard to make it easy for you for your first encounter with it to send it out there. You tell your developers to use stages, and stages are equivalent basically to Lambda versionings and as well as aliases to maintain different API versions that are mapping to the same Lambda versions, right? And API Gateway and Lambda is going to be at the heart of everything, right? API Gateway is the best way. It integrates obviously directly with Lambda, and it's the best way to receive, any basically API calls, custom APIs, and as well as, it will integrate with Cognito, provide you with authentication, all these wonderful things, and then, Lambda can then make API calls to any of those other services that we talked about very easily, and those can actually work in isolation themselves. And then try to always have separate stacks for development, testing, staging, production environments. So, don't allow that like a simple kind of change of a variable can make a difference between, a staging and a development or a production environment. The most errors really become human errors in the end. Yeah, things do fail and stuff, but for the most part, those things, we take care of pretty well, I think. If you look at, the way kind of our availability zones are clusters of data centers that are geographically displaced on a different flood and fault plane and all that. It's very hard that, a meteor hitting even, or a utility company like, switching off electricity or something like that will affect us. But human error will most definitely affect, the availability and running of your service. Start with the AWS Codestar. If Codestar will build all this for you that we just talked about. You have a lot of examples in there for serverless architectures. Nick mentioned Alexa skills and other things, but there's also different types of serverless kind of examples with different languages. And it will set up the entire CI pipeline. It will seed it with their test code and stuff. You can replace it with your own code, and you can start working with it. In fact, it will allow you to create a project team. It will integrate with Jira if you want. And you can start working in it as, in a full kind of CI pipeline and development environment. It will instruct you even how to set up your development environment for running it and all of that. So it does pretty much a lot, and we keep on adding more and more templates for different development projects in it. If you go to Amazon, AWS, Amazon.com serverless, you can check out a lot of our different use cases, a lot of different architectures. You can check out what our customers have done, what our partners have done, what have they got to offer, how well it works with the rest. Don't forget that we do have thousands of ISVs, thousands of different solutions as part of our marketplace. Consider those, check those out. There's a lot of appliances there where our, different ISVs have built, and our very valued partners have built to simplify and do and address specific use case scenarios for you, and they integrate and work really well with the rest of our serverless services. And in the very end, thank you very much. This is Nick's and mine email and Twitter. If you have any questions, if you want to dive deep into any of these aspects, please come to us right now. We got nothing to do until dinner. So come and ask us. Follow us on Twitter. Nick was just saying, you're very active on Twitter. So if you want to check out new things that are coming up, I do post them. I do, if you have any questions or anything, I'm more than happy to answer, and I do that often. Thank you very much.
Thank you, guys. Thank you.